Okay, this is part 2 of hypothesis test. Last time we talked about getting a p-value. Basically what we're trying to do with p-value is our sample unusual? So according to rare event rule, if we have unusual event, then what we're going to do is we're going to reject that. For example, if somebody says, I'm going to win a lotto jackpot tonight, well, probably if that happening is very small, so your brain is like, no, I don't think you will. That just means rejecting the statement. So keep in mind that rare event, unusual event, we're going to reject that. So the reason we calculated p-value is to figure out if our sample is unusual event or is not. If our sample is unusual, then going to reject. Otherwise, we can't, right? So our next step is going to be we make a decision about our null hypothesis. Remember, null hypothesis is the part that we're going to assume that is true. So according to the null hypothesis, we're going to see our sample is unusual by looking at our p-value. So by comparing the p-value to the significance level, significance level alpha. If p-value is less than alpha, that basically means p-value is small. That means it's an unusual event. That means you're going to reject H naught. Notice that we're rejecting H naught, not HA or something else. So I want to make sure you know what you're rejecting is H naught, which is what we assume to be true in the very beginning. And next part, if p-value is greater than or equal to alpha, then we fail to reject, again, H naught, right? So basically in my head, if p-value is small, that means our sample is unusual. That means I'm going to reject what we assume to be true, which is H naught. So this is basically what we have to remember when it comes to our decision. And if p-value is not small, then our sample is not unusual. That means we failed to reject H naught. So that kind of follows. So we should write that down. P-value is not small. That means our sample is not unusual. That means we fail to, or we don't reject, you can say that also. We fail to reject H naught, so that follows. So every hypothesis test will have two starting decision. Either we say blah, 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 reject H naught, or blah, 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 fail to reject H naught. Depends on our p-value. All right, let's look at the next question, number 11. It says using p-value from number 9 and the significance level 0.05. Again, significance level sometimes is not given to you, so usually this is a default level. Make decision about H naught. Number 9a, from last section we calculated the p-value of 0.039, which is basically 3.9%, which is less than 0.05, which is 5%. So our sample is unusual. That means we reject H naught. So I'm going to have you pause now. I'm going to finish number 11. All right, and let's look at the next part. So what happens after we make our decision? After using the rare event rule to make a decision about our null hypothesis, we need to tie the decision back to the original claim. This takes us back to the final part of the hypothesis test, the conclusion. We describe the result in terms of our original claim in the form of a meaningful conclusion. So this is what we're going to do. If we reject H naught, and the original claim was also H naught, then the sample data suggests that we reject the original claim. Because the original claim and H naught are basically the same statement, so if I rejected H naught statement, basically I'm also rejecting the original claim statement as well. So if that's the case, we're going to reject the original claim. That's going to be our final conclusion. if we rejected H naught, but the original claim was HA, and remember HA and H naught are opposite of each other, then sample data suggests that we support the original claim. Because they're opposite of each other, if you're rejecting H naught statement, basically I'm saying H naught statement is wrong, but HA statement is opposite of that, so basically I'm saying, yeah, then that is correct. So these two are basically scenario case 1. This is case 1 where we decide to reject H naught. If we fail to reject H naught, that basically means our sample data suggests nothing unusual has happened. So there's nothing to reject, there's nothing to support. Basically, is insufficient evidence to reject or support the claim. You can also say inconclusive. So you can't basically make any decision. I cannot say something is correct, I cannot say something is false. In conclusion. So you probably hear that on the news or articles as study was inconclusive. That means it failed to reject H naught. So this is case 2 where we are basically inconclusive. All right, let's look at the next question here. Number 13. Fill in the blanks and write down the decision and meaningful conclusion. Okay, let's get part A. A newspaper claims that over 50% of Californians support the prolonging stay-at-home order. Okay, first of all, I notice it has 50%, so it's percent, so most likely it's a proportion question. So I'm gonna use letter P. So basically our claim is gonna be either about the mean or about the proportion. Here it's about the proportion, so I'm gonna use the letter P instead of mu. And it also says over 50%, so that means greater than 50%. So I'm translating in my head, P is bigger than 0.5. It doesn't say at least 50%. It doesn't say more than or equal to 50%. It just says over 50%. So I'm going to use strict inequality symbol. So that's going to be my claim. And I noticed there's no equal sign in it. So it's going to be our HA alternative hypothesis. So I'm going to write P bigger than 0.5. Again, H naught is opposite of that, so opposite of bigger than is less than or equal to. So P less than or equal to 0.5. So this is going to be our original claim here. Normally we'll calculate p-value ourselves, but here p-value is given 0.025. So at first I thought, okay, that's pretty small probability because it's basically 2.5%. But however, significance level here is 0.01, which is not 0.05. So basically what it says is anything less than 1% is small and anything bigger than 1% is not small. So in here I noticed that p-value is then bigger than alpha. So that means p-value is not small. That means it's not unusual. That means I'm going to fail to reject the null hypothesis. So our decision is going to be fail to reject H naught because p-value is bigger than alpha. And I noticed that the original claim is HA, which is opposite of H naught, and we failed to reject H naught. If we reject H naught, we'll support HA, which is the original claim. But here we failed to reject H naught, so we'll kind of do the opposite, which is fail to support the original claim. Claim. You can here also say inconclusive because we failed to reject H naught. So you can say inconclusive. So basically what I can say is we don't have sufficient evidence. We don't have sufficient evidence to support the claim that over 50% of Californians support the prolonging stay, support ... Being lazy here, right? So this will be my final conclusion is we don't have sufficient evidence to support the claim. That basically is saying you failed to support the claim. All right, I'm gonna have you finish number 13 and we'll meet back at number 14. All right, so for number 14, we're gonna actually do the hypothesis testing from the beginning to the end. Let's look at the first, number 14, we'll do that together, and I'm gonna have you finish the rest of the worksheet. All right, number 14, it gives you a lot of information. So here, I'm gonna kind of look for what statement is that we need to actually test. So let's look at this statement that I'm underlining or highlighting here. A researcher wants to test, okay, so I noticed that he wants to test something. If the percentage of the US students who takes advancement placement exam is more than 6.6%, okay? So they give you a lot of different information here, but I want to make sure that I'm looking for the one they actually want to test. So they want to test if the percentage of the US student is more than 6.6%. Again, I noticed that they're talking about percentage, which is proportion. So I'm going to use letter P. And they say they want to test if it is more than 6.6%. So P bigger than 0.066. So the first step is to write the claim P 0.066. Again, I didn't use the letter mu because we're not talking about average. You're talking about proportion. H naught and HA, I noticed that the claim doesn't have an equal sign in it. So this is going to be our HA. And that means the H naught is opposite of that. Again, opposite of greater than is less than or equal to. So I'm going to write it like this. Oops, 6. Here we're using proportion, so it's Z. Calculate function key, I'm using 1 prop Z test. So 1 proportion. So whenever I use whenever I'm testing for T, I'm using proportion, PROP, Z test. All right, so once you go there, they're gonna ask for P naught, X, N, and prop. They want this sign or this sign or that sign, right? So P naught, basically they're saying, give me a P that you wrote under H naught. So 0.066, okay. That's the value they assume to be true. X is number of successes. Okay, what does it say? When they surveyed 50 people and then 18 took AP's classes. That means 18 is the number of successes out of 50. Let me come back here. So 50 is the sample size and 18 is the number of successes. And the next I have 3 inequality symbol. So which one am I supposed to pick? I'm looking at HA. So here, look for HA. Well, my HA has the greater than sign, so I'm going to pick that part. And once you calculate this out, give you a bunch of information. My p-value basically is what I need. So p-value is 2.8 something something e negative 17. You notice that it's kind of weird. 2.87 e negative 17. When you see that e negative 17 or e positive something at the end, that means basically it's in scientific notation. I notice it's negative 17. That just means it's very small number, almost 0. That means move your decimal 17 places to the left because it's negative. So basically it's 0.0000283. It's almost 0, right? So almost 0. So p-value is almost 0. If I were to graph it, it's right tail because HA points to the right, and basically your sample is basically here. So this is your p-value is almost 0. So this is very, very unusual event, right? So our decision is gonna be, because p-value is way less than alpha, we reject. So in my head, this is very unusual sample. That means we reject H naught. Okay, so my last step is my H naught. I'm looking at the original claim. Original claim is HA. If I reject H naught, because I'm saying this is wrong, that means I'm saying the opposite is true. So it's always going to be the case where when you reject H naught, you're supporting HA automatically. So in this case, because our original claim happened to be HA, what I'm gonna say is we support HA. So I'm gonna actually make a statement. So we support, there's sufficient evidence to support, we support the percentage for US is more than 6.6%. So I'm kind of repeating what the claim says. So I know I'm kind of repeating the same thing, but for conclusion, I'm gonna just write down the whole statement. So for the quizzes and exams and stuff, I know it's kind of redundant, but I'm gonna have you, for the conclusion, I'm gonna have you actually write down the claim kind of again in some ways, because on the newspaper, on the article, this part is what you see. So I just wanna make sure that you can write that. All right, I'm gonna do one, let's do one more question together. Let's look at number 16. All right, the winning time in seconds of men in 100-meter dash are, the bunch of numbers are given. So notice here, the data, actual data is given to you, so fine. I think there are 22 numbers there. Test the claim, the average, the mean time is 10.5 seconds, okay? So this is test about the mean, so I'm gonna use letter, symbol mu is equal to 10.5, so that's my claim. Again, here I'm not using P, which is a proportion. Here I'm looking for the average or the mean time, so I'm gonna use letter mu. All right, so the claim has equal sign in it, so that's gonna be our H naught. It's gonna be original claim here, and then opposite of that is HA, so not equal to is that. Here we don't see the population standard deviation, so this is gonna be my t distribution. That means we're gonna use t-test instead of z-test. So on your calculator, you can go stat and tests and pick the second option, which is the t-test. Then it'll ask you a bunch of stuff. Input, in this particular case, we actually have a data set. So I'm gonna use data. So what I'm gonna do is I'm gonna input those 22 numbers into L1. And I'm gonna use that list to do our hypothesis test. So I inputted all 22 numbers in L1. So I put data, mu naught. Again, this is mu that we have in H naught. So I'm looking at H naught. Mu is 10.5, so I'm gonna put 10.5 there. Next, they ask for the list. I put it in L1, so I'm gonna put L1 frequency. For this type of question, frequency is gonna be just always 1. And the last part, the inequality part, is gonna be, I'm looking at HA. HA has the not equal sign, so this is what I'm gonna input. So when you calculate that out, what do I get? Enter. P-value is pretty big. I get 0.828. All right, so again, p-value is pretty big. It's 80.8%. So here, p-value is 0.828. What that means is our sample is, it kind of covers 80%. So there's two tails. So either our sample is here, so it's not something unusual. Something unusual will be like way in the tail. So my decision is, because p-value is way bigger than alpha, that means our sample is not unusual. Again, I failed to reject something that's unusual. So I failed to reject H naught. All right, so our last step is, I have to kind of declare, okay, what I'm going to say to the claim, we failed to reject H naught, and then claim happened to be same as H naught, so I'll just repeat what I just say. So here I'm going to say fail to reject the claim. So my official answer is we don't have sufficient evidence to reject the claim that the mean time is 10.5 seconds. All right, so that's my official conclusion here. We don't have sufficient evidence to reject the claim that the mean time is 10.5 seconds. All right, so I'm going to have you finish the rest of the worksheet.